So this video is for integrated 3. This is the second part of the chunked extra practice. This is the homework one. So on this, just like the one earlier, we're going to be trying to use synthetic division to find all of our roots here, all of our zeros. And we're going to be doing P over Q. Now, the first thing I want us to notice is this is an x cubed, which means that this is a degree 3. So I'm going to have 3 solutions. So let me just kind of make a note about that. So degree 3 means that we are going to have 3 solutions here. Okay, we're going to have 3 solutions. Then I'm going to be looking for my P over Q's. My P here is this 3. So I'm going to want all factors of 3. And my Q, I'll do it in purple. Our Q is going to be a 1. So when I do P over Q, the nice thing here is that since my Q is 1, I'm going to get all integers. Okay, so really it's just going to be all factors of the P, so plus or minus 1, plus or minus 3. Those are what I'm going to try. Want to make sure that I have every term here, x cubed, x squared, x constant. If not, I would put a 0. So I am going to have a 1, a -3, a 1, and a -3. Okay. I'm going to start with a 1. Let's see what happens. So I'm going to do 1. I bring down my first number. So bring this down. 1 times 1 is 1. I add it to -3. I get a -2. -2 times 1 is -2. I add it to 1. I get a -1. -1 times -1 is -1. I add it to -3 and I get a -4. Okay. So let's try a 2. And just kind of a quick note, I did tell you guys that if we're using a positive number here, and we look at all of these results that I'm getting here in this depressed polynomial, if these are all positive, then that would have been an upper bound. And so I wouldn't try anything over 1 because I'm not going to have any zeros go beyond. But that's not the case. So I still have a 0 out there. Also understand that this is really my 0. I'm at -3. That's my y-intercept. This is saying that at 1, I'm at -4. So right now I'm going down, but I'm going to be coming back up because, again, this is saying that there's another 0 out there. Okay, let me just do this one in a different color so we can see it a little nicer. So that's a 2. I'm going to try. And I'm not going to try a 2. Why would I try a 2? I'm not going to try a 2. My 2 numbers that I'm going to try are 1s and 3s, positive, negative, 1s and 3s. So I'm going to try a 3. Okay, I'm going to try a 3. Bring down my 1. 1 times 3 is 3. Add it to -3, 0. 0 times 3 is 0. Add it to 1, 1. 1 times 3 is 3. Add it to -3, 0. Okay, so this was 3, 0, but what it is a solution. Okay, that is a solution. So when I start with a degree 3 and I find my first 0, stop, take that and now write it as a depressed polynomial, 1 degree less. So it's going to be an x squared plus 1 equals 0. We're going to solve this. I'm going to minus 1 from both sides. When I do that, I'm actually going to end up getting answers that I would not have found if I did not stop. I'm going to get a positive and negative. And when I take the square root of a -1, I get I. So my 3 answers, x equal 3, x equal positive and negative I. Those are my 3 solutions. I never would have found those imaginary ones if I kept trying these values. So let's now take a look at number 2. Okay, on number 2, we're going to be sketching a graph of the polynomial. First off, it's in the factored form. So I don't just look at the biggest power. I'm going to combine all of them. So this, let me write it above it. So this is degree 1, plus this is a degree 3, plus this is a degree 2. So I'm going to get a degree 6, and it is negative. Okay. So when I have a negative degree 6, I think of evens as parabolas and odds as lines. So a regular positive parabola would be opening up. But we don't have a positive, we have a negative. So we want to think of it like an upside down parabola. We're going to be starting below, ending below. That's what's going to be happening. Now, our zeros, we have x equals 0. That's a single. We have x equal -1, which is a triple. We have x equal 2, which is a double. So I want to pay attention to that. Okay. So I am going to go out 1, 2, 1, 2. I have a 0 at 0. Okay, that was this one, which is a single. I have a 0 at -1, and that's a triple. So I want to pay attention to that. And I have a 0 at 2, and that is going to be a double. Now, when I am drawing this, it is going to be starting below because it was a negative even degree. So I'm going to come up to the first one, which was a triple. So it's going to look like a cubic graph. So I think of it as almost half of an open down parabola almost. And then it's going to switch concavity and become half of an open up parabola. Now it's going to come through this 0 as a single. Let me make it more. Sorry, my okay, so that is our triple. It's going to come through this like a line, okay, because it's a single. And then when it comes up to this next one was a double, so it's going to bounce back like a parabola. On number three, we're going to divide. Didn't say how we're going to divide, but if this is an x plus something or an x minus something, we can use synthetic division instead of long division. So I am going to put a -2 in the box because that's what makes this 0, x equal -2. And then I am going to be writing my coefficients, but pay attention, there is no x term. So this is an x cubed plus 5x squared plus 0x minus 8. So I'm going to write 1, 5, 0. Don't forget that 0 because we don't have an x, -8. I am going to bring down my first number, which is a 1. 1 times -2 is -2. That combines and gives us a 3. 3 times -2 is -6. That combines and gives us a -6. -6 times -2 is a 12. That combines and gives us a 4. So if they had asked, is x plus 2 a factor? Our answer would be no, because our remainder is not 0. Our remainder is 4. But they just asked us to divide. So now we need to give our answer as a polynomial in standard form. So it was a degree 3. This is now 1 degree less. This is a degree 2. So this is going to be x squared plus 3x minus 6. And then this is a positive 4. So I'm going to write plus 4 over, because that's our remainder, what I divided by, which is x plus 2. And that's our answer. Okay. On number 4. So on number 4, you want to be careful and read the directions. It says, list all possible rational roots. It's not asking us to solve. Okay. So that means we're going to just do our P over Q. So our P is this -11 at the end. Our Q is this 5. So I am going to be taking all of my factors of P over all of my factors of Q. So my factors of P, factors of 11, positive, -1, positive, -11. My factors of 5, positive, -1, positive, -5. And so what I'm going to be doing is I am going to be putting my positive -1 over 1. And that is going to give us a positive -1. I'm going to put our, let's see, hold on. Okay, sorry, I was just changing color so I could move these a little easier. Okay, so what's happening here is I am taking this positive -1 over positive -1. Then I'm going to take this positive -11 over positive -1. So I'm taking both of those over the 1. Then I am going to take both of these over the 5. So I'm going to go 1 over 5, and that's going to give me a positive -1/5. And then I'm going to be taking the positive -11 over 5. So that's going to give me a positive and -11/5. So 1 over 1 is 1. 11 over 1 is 11. 1 over 5 is 1/5. 11 over 5 is 11/5. This is our answer. They are not asking us to solve. They're asking us to list all possible rational roots. On number 5, they want us to expand this. So a quick note here. I'm going to think about this z as being raised to the 6/7, because the 6 is the power and the 7 is the root. So power over root in terms of a fractional exponent. I'm going to have a log for the x, a log for the y, a log for the 3, a log for the z. So I am going to have log of x plus, I'm going to write this, but I'm going to change it, log of y squared, but my square can move in front. Okay, so that's going to be 2 log y. Minus, because it's dividing, it's on the bottom, it's in the denominator, log of 3 minus, and again, this is going to be log of z to the 6/7, but that 6/7 can move in front. So I am going to end up getting 6/7 log of z. And that is my answer in expanded form. On number 6. Okay, so we are factoring. First thing I notice is that I can factor something out of both of these in terms of numbers. A 4 and an x, a 4 and a 32. I can factor a 4 from both of them. And then if I'm looking at this x to the 4th and x, I can factor an x out of both of them. And so I'm going to be left with x to the 3rd minus 8. Now, that x to the 3rd minus 8, I can factor that. That is a difference of 2 cubes. Now, let me write the formula for a difference of 2 cubes. A cubed minus b cubed equals a minus b times the trinomial, where I square the first term a, so this term, change the sign, plus, multiply together ab, and I square, so that's a b squared. So that's our formula that I'm going to be using. So I am going to have a 4x. I'm going to have a 4x times, And this is going to be an x minus 2 because that is the cube root of x and the cube root of 8 times, and now I'm going to square this x, so that's an x squared. Change the sign so it's opposite, so that's going to be a plus. Multiply together 2x and square 4. And again, I am just using the formula that was right up here, okay? And this is called difference of two cubes. And that is going to give us our final answer. They did not say that they had to be linear factors, so we're fine like this. On number 7, okay, we're solving the log. Now, this one's different than the one from the other worksheet. On that one, I had a log on one side and a log on the other side. So I got one side to be a single logarithm, which is what I'm going to do now. Okay, I'm going to do that right here. I'm going to make this a single logarithm. So this is going to be log base 2. Let me just log base 2 of, oh, sorry, and it's not going to be, let me write a bigger parenthesis. Sorry, trying to erase. What am I doing? Okay, so log base 2 of, and because it's a minus, my x and my x minus 1 are going to be dividing. Okay, not multiplying like they did in the last problem. But this is equal to 3, not equal to another log. So I cannot take this x over x minus 1 and set it equal to 3. I could only have done that if it had been this. Log base 2 of x over x minus 1 equals log base 2 of 3. Then I would have taken this and set equal to this, but that is not the case. So I cannot do that. So what I'm going to do is rewrite this in exponential form. So my base is 2. My log always is equal to the power. That's why we have logs, to find the power that we raise a particular base by to get a particular value. So my power is 3 is equal to x over x minus 1. And 2 to the third is 8. So 8 is equal to x over x minus 1. I am going to multiply both sides by x minus 1. When I do, this and this cancel out. I end up with an 8x minus 8 equals x. I'm going to minus 8x from both sides, so I get a negative 7x. And so I get x is equal to an 8/7. Now, you go back to your original problem. You want to make sure that when you put that in, when you put this in to both of your logs, you do not get a negative in either one. And in this case, we're not, because 8/7 is positive. So the first one's going to be fine. The second one, 8/7 is bigger than 1. So when I subtract 1, I'm not going to get a negative. So my answer is 8/7. That is going to work. On number 8. Okay, so we talked about this on the other worksheet that first off, standard form means we're going to multiply it out. If we have this imaginary root, remember they come in pairs because of the quadratic formula. So your i's are always going to have conjugates, and your square roots, because I is really a square root, but if it's just a square root and it's positive, you're also going to have conjugates because of the quadratic formula, because of the x equal negative b plus or minus, that part right there, b squared minus 4ac all over 2a. So right here, this plus or minus, that's giving us our conjugates. And notice that the plus or minus is in front of the radical, which would either give me an I or a square root if it was not a nice number. So that explanation leads to the fact that not only do I have an x equal 2 plus 5i, but I have its conjugate, x equal 2 minus 5i. That is also a solution, Okay, so I also have this conjugate. So now I'm going to be writing out my factors. So when I write my factors, let me just, I mean, write out my problem. Let me just do this. So I'm going to have an x So if I'm looking at my factors, okay, or not my factors, my roots, I have a 2 plus 5i. I now know that I have a 2 minus 5i also because those i's always come in pairs, conjugates, and I have an x equal -3. So this is going to be degree 3. So when I'm writing my factors, I want to think what's the opposite of this because that's what's going to be combining with our x in the parentheses. So this opposite would be a -2 minus 5i. So that is going to give me x minus 2 minus 5i. Here, what's the opposite of this? The opposite of this is a -2 plus 5i. So that's going to give me an x minus 2 plus 5i. And then what is the opposite of this? And I think we all know how to do this. That would be a 3. So this is going to be an x plus 3. And now we're going to multiply these together. We're going to multiply our ones that are conjugates together first. I'm going to end up with something that doesn't have an I. So I am going to do a 3 by 3. Okay, 3 by 3. So I have an x minus 2 minus 5i. Watch your signs. X minus 2 plus 5i. And now I'm going to multiply. And when I multiply this, I'm going to get an x squared minus 2x minus 5ix, which should cancel out here, minus 2x. Okay, now be careful. This is a minus 2x and a minus 2x. Those don't cancel. That's going to be a -4x. My -2 and -2 give me a 4. I get a 10i. That should cancel here in a second. Now, when I multiply by the 5i, I get a 5ix. So these will cancel. I get a -10i. So these will cancel. And then here I'm going to get a -25i squared. And an I squared is a -1. So this is going to be a positive 25. So again, what's going to cancel out? This is going to cancel with this. This is going to cancel with this. And I am going to be left with x squared minus 4x plus 29 is going to be multiplying with x plus 3. And I'm going to do this, which is going to be a 3 by 2. So I have my x squared minus 4x plus 29. I have my x plus 3. And when I multiply those together, I get an x cubed minus 4x squared, 29x, 3x squared. I get a -12x. And I get, when I take 3 times 29, I'm going to get a 87. And then I'm going to combine like terms. And when I combine like terms, my final answer is going to be, x to the third minus x squared plus 17x plus 87. And that's my answer in standard form. On number 9. So on 9, they want us to find the exact equation. Okay. So exact equation, and they gave us a point. That's the point we're going to put in. Looking at this, it's ending and starting in opposite directions. That's going to be an odd degree. And again, odd degree, I think of as a line. Positive increasing line, negative decreasing line. Even degree, I think of as a parabola. So open up, positive, open down, negative. So you see that we're going in opposite directions. And I'm going starting from above, ending below. So that is going to be an odd degree. Okay. So just keep that in mind. Don't put your negative in. You'll get your negative when you put in your point. Okay, so let's find our x-intercepts. Okay, so pay attention to how they cross. So my first one here is at -3. That is going to be an x plus 3. But we want to pay attention to how it is. It does not just go through. That would be a line. So we see that it comes almost like half of an open up, switches to like an open down parabola. So that is going to be an x. That's going to be a cube. Then it's coming up to this here at 1, which would be an x minus 1. It does not go through. It bounces back, which is like a parabola, so that's going to be a square. I only have 2 places that it touches the x-axis, okay? Now, 3 and a 2 make a 5, so that is an odd degree, so that's looking good. So I'm going to have y equal a, and I'm going to have my x plus 3 cubed and my x minus 1 squared, and then I'm going to be putting in my point, which was a 2, -4 for my y and my x's. Okay, so when I put that in, I'm going to have -4 is equal to a times 2 plus 3 cubed, 2 minus 1 squared. So -4 is equal to a. I'm going to get a 5. 5 cubed is 125. I'm going to get a -1, I'm sorry, a positive 1. 1 squared is 1. So I have -4 equals 125a. So -4 over 125 is going to be my a. Okay, don't do all this work and not give the final equation. So y is equal to -4 over 125, okay, times our x plus 3 cubed and our x minus 1 squared, and that's our answer. On the next one, oh, is that it? Oh, we're done. Sorry, thought we had one more. Okay, so hopefully this helps you on the homework. Make sure that you guys are just using this as a check, because you need to understand how to do these. Some of these were difficult, okay, but hopefully after seeing this, you will be able to do it when we do a D-Day, when we do a group quiz, when we do a test. And that's the end of this video.